Sorry. Hi, my name is Francisco Sanchez, and this is my stats project, which is on the price correlation with the internet and Bitcoin. So, essentially, what I'm doing here is that I am using social media, for example, Twitter, to find out if words can affect the price of Bitcoin. Like my null hypothesis states what words people say on Twitter can affect the price of Bitcoin, and the alternative hypothesis is words that are used on Twitter can't affect the price of Bitcoin. So really what this is just saying is that, well, if someone says something, if a group of people really say something bad about Bitcoin, it will have a correlation with, the price of Bitcoin. Like if it's around 100 people say, "Oh, you should invest in Bitcoin," but 100 people say, "No, that's a horrible idea," the price will stay the same. But if 100 people say you should invest in Bitcoin and only one or two people say it's a horrible idea, don't invest, the price will go up, and vice versa. Where the data was obtained, secondhand data really from Kaggle Coindex, and what Kaggle is a, how do I describe this? It's a data analytical company, basically, where they have a built-in text editor for analyzing data, like using Python and R to look at data and observe the data and come to a conclusion, which is the website I used for a good chunk. That's probably half of my project. And Coindex is where I've obtained the data for Bitcoin, and it's just a place where people go to look at the price of certain cryptocurrencies, and really that's about it. You can invest on Coindex, and they usually obtain their prices from hundreds of different sources. And Kaggle, the way that data is obtained is individuals or groups of people will usually go through hours and hours and mostly like months and days of trying to find certain data points, like tweets, for example, is really what I used that for. It might have been just one person scraping through Twitter to find tweet data. And this is where I'm going to cut to my code. Alright, and so as you can see, there are two CSV files where I have my tweet data, which is the Bitcoin underscore tweets, and then my Bitcoin price data, which is right here. And it's under crypto data, which is my file. I don't know if you can see that. I don't think you can, but you can also see it right here where the full file is at. Or you can even, let me show you. Just 10 rows of Bitcoin. This will take a couple of seconds. It's Python. Python's notorious for being slow. Yep, there you go. 10, 11 seconds, Jesus. And you can see all my data is from, that isn't really relevant anymore. It says reverse order, it's all fixed. As you can see, the prices are from the 28th of December from 2013 to when I first got the data, which is the 23rd of April, 23rd of April in 2024, this year. And it's obviously on the website's updated, but I don't know, just for my sake, I'm not getting up-to-date data because I don't really need to for this project. And because I showed you the Bitcoin data, which I'll get more into it. I'll show you my data, which it's not the best name for what that is. I really should have just used tweet data or Twitter data. And yeah, as you can see, Twitter, it's tweets, and we got the languages right here, and we got the dates right here, and we got the text right there. And just for sake of scrolling, I'm gonna get rid of that. And these right here is just more the conclusions that I came up with. I'm spoiling some stuff. Right, I'm gonna cut back to. Alright, so I had to narrow down my data points for this project. I had to narrow it down because I don't want to go through hundreds of tweets in different languages to find out if there's, what words they're using or what no words they're using, like, positive or negative. And really, I narrowed it down to 92 data points, which really limits the Bitcoin prices. And I'll just show you the prices not the prices, the tweets I have right now. So I'm cutting to my code right now. And you can see here, I limited it down. This is just more where the positions were at. And as you can see, there are 92 data points, but it's not 1, 2, 3. I fix that later on, but right now I don't really need to. And you can see the languages are all English, and that's done by this snippet of code, Alright, and I also had to figure out which row of the Bitcoin I had to use. Well, the Bitcoin data that I had to use, and so I'm going to cut back to the code for you can see that. Hey, that's an improvement. 10 seconds. That's 1 second improvement. It's probably not going to be that again. So as you can see, I've right down here I stated that I'm going to be using the closing value because it's the outcome of the day, which the tweets, they usually go up to the end of the day, which minus the last couple of tweets, they only go up to 4 p.m., which caused an outlier, and I cut the outlier out early on because it really just, I don't know. I'm not going to show it in this, but it really just messed everything up. And it's not really much of an outlier, it's more of like an incomplete data set. So I don't know why I called it an outlier, it's not really an outlier. And so the reason why I had to use the outcome is that it's not the outcome, the closing values, is because it's the final value of the day. And like I stated before, the tweets go up usually to the end of the day or near the end of the day, because people are online 24/7. Alright, and let's see here. No, that's later on. So really what then I had to do was I had to combine the values. So what I did was I got the English only as shown, and then I had to figure out the count for the positive and negative words. I don't really use the negative words because the positive words, they should, counteract, so the positive words should be enough to, show the correlation between the closing value and how people's feelings affect the outcome. Well, people's tweets affect the outcome of Bitcoin for the day. And as is shown, this chunk of code, which is called a cementer, or I don't know the actual official term, but it basically detects words that have emotion, basically. And this can be shown with, my set of word data, which is, all the way up here. You got the negative words and the positive words. Yeah, that's there. And what it does, this fixes the data so it can be, fixes the text from the tweets so it can be commaed. So the sentiment detector can look at the words. So you got 1 for word in tokens, if word in positive words. So that basically what that means is that it looks if the word is a positive word, and this basically does the same thing but with negative words, and this returns that value. And this right here, what this does is it fixes the data to, have the count, essentially. And what else do I do? And this right here is it fixes the date, essentially. Yep, it fixes the date right here. And so the reason why where does that up here? No, this right here, this fixes the date. Well, it fixes the date half of it. This fixes the other half. The reason why I had to fix the date was because, as you can see here, this screws up with everything else. And the reason why I had to fix it is that these values are not combined, aka the computer will not be able to detect if it's in the same day. It will just have a graph that looks relatively flat because of all the data points. And so essentially what this code does, what this code does is that it generalizes or just combines. It combines basically. You can tell by the sum function right here and the reset index function. It combines all the values for the positive and negative counts. And and the code snippet up here, it drops all the days that have a null value or not a number value. And right here you get my magic number 92. You're going to see this number a lot. Alright. So, really, what this code leads up to is this. A x positive value, aka the positive count for the general test data, aka the the positive count, essentially. And so the general test data positive count, what that equals to is the positive count at the closing value, which is this little what's called a data frame, which is essentially it's just a matrix of just multiple values, essentially. And cutting back to the PowerPoint, taking a first look at the numbers, there doesn't really seem to be really much correlation between the two sets. And I'm going to cut to the code in there. So what this does right here is, it takes the count of the positive count and the Bitcoin data of the closing value, and goes into this function right here, which I have all printed out, and the 5 number summaries right here. I added on the mean and standard deviation for later uses, but as you can see here, you have the 5 number summary of the bit sample and the positive sample. But everything looks fine and dandy here. It's just the the maximum for the positive sample doesn't really match up with the minimum. And the reason why I'm saying that is that if people are talking the most positive about a thing, about trading, it's usually about, oh, right now is the perfect time to invest because the price is so low. And as you can see, what value is that again? Which, right here, it's not really close to the minimum value for Bitcoin. In fact, what was the minimum value? Is here, right here, which is 8,000, 8,500. It's quite a bit, but at the same time, it's way less. It's a bit less than 10,000. Which, in hindsight, it's not that far away, but it's a decent far away to be significant, especially when the minimum value for this and the maximum value for that aren't really that close. It's right there. That's 6109 at 83, and the maximum is 747. It's up there, decent way, more significant amount than the maximum and the minimum of the of their own 5-number summary. So the way that I would interpret that is that the null hypothesis does not seem to be as correct as I would think, and this could also be shown with how closely similar these the positive count is from each other. It's only 4,000 away from the maximum, so it has a nice amount of room to work with. But at the same time, if it was this was the x values. If the x values were more compact, as I would think, as I would hope so, it'd be easier to show the correlation. But I would predict 2,000-ish away from each other, because if you look at the values from here, they're going to be high, which that doesn't really have any meaning. But ultimately, you know what I'm trying to say. The values for this should be closer to each other, so it can show a better correlation with how it's going to be set up for the scatter plot. Alright, I'm going back to the PowerPoint. So, alright, Frank, you're going to have to cut out that I went back to the PowerPoint. And so start off where it said, start talking about scatter plots. So what the scatter plot shows is, I have a little note thing, little page, I think, is what notebooks are, who cares. As you can see with the scatter plot, all the data points are spread apart. They're all, you would assume that these are outliers, but they're not. All the data points right here and right here. But they're not outliers, sadly. Let me scroll down here. As you can see, these are the data points with the outliers highlighted. They're not highlighted, obviously, which sucks, to be honest. But if what if you were to apply like a not linear regression, but a logarithmic regression, it would make the data points more aligned. But I didn't do that. Hold on, cut out that logarithmic thing. But if you were to apply linear regression, these points would all be all over the place and would just not fit well, I predict. Oh, let me do that again. If you were to put a linear regression to this, it would not fit that well, I predict. Alright, and really, because of this blockiness, or, well, low correlation between these points, really low correlation between these points, one can assume that the alternative hypothesis of where it's not really having much correlation with the price of Bitcoin is true. Well, singular words on their own being, the correlation not being true. Alright, I'm going back to the presentation. Now, based on the scatter plot, like I said, there's going to be a low correlation, and I believe the t-square is going to be high, really high, and when I showed it, when I, coded it, it was really high, around, 40, or something around that, which I'm going to cut to the code right here. And to show the t-value, I'm going to execute this and hope it doesn't. Alright, took barely any seconds. And as you can see, a t-score of 41, almost 40 and a half, is really, really high, especially if I'm comparing it to like what, 4, -4 and +4, which is in place for the standard deviations, which is just alright. I'm going to cut that +4, -4 thing out, which, if it's compared to how the graph is set up, is just crazily bad. It's just wow. That t-score is so not good at all. It's not really good for predicting the actual mean at all. And yeah, and I'm going to cut back to the slide, really. And so what I did with the t-score is use a t-distribution, and what that is as shown with the this, the image describing it. It is, just really, it's simple. Especially t-distributions were made for smaller samples, like 100-ish almost. That's why I have 90. Wanted to get 100-ish values, which honestly 92 values is perfect, especially for what I'm doing here. Well, because I'm using a t-distribution, it's perfect, especially for what I'm doing here. And really, this is where the real hypothesizing begins. Alright, and as you can see, I coded it up like this. I had a lot of comments. I know what I'm thinking or doing, really. And this is the output. That green line, that's the t-value. That's off by a ton, by a lot. And right here, you got the t-distribution and the normal distribution. If you look close enough, which I can't really zoom in. It's going to be really hard unless I would take off the T value. You could probably see more easily. Which, can you? No, I can't really. It's essential though. And as you can see, the critical value right here. This is where this is where I would really want the t-score to be in between these two values, so I can go, okay, hey, I'm at a negative mean, or not negative mean, I'm on the opposite side of the mean, I should, sell, or I'm on this side of the mean, which is the positive side of the mean, which I should, buy because the price is so low, which, because of the t-value being all the way over here, it is extremely super duper safe to assume that the null hypothesis is wrong. And yeah, that's really all I have to say about the in-depth hypothesis. You can see the t-value, the critical value, degrees of freedom right here, and it even says reject the null hypothesis right there. And using my human eyes and brain, yeah, no, that makes perfect sense why you would want to reject it, because look at it, it's all the way, it's God knows how many standard deviations away from the normal curve in the t distribution. Alright, cut back to the slides. What I'm going to do is use the least square regression model to see how a line would look through the scatter plot and see how accurate the data is. But based on the t distribution conclusion, it's not going to look good. It's not going to look pretty at all. It's just going to look like almost straight line, but not really. And really, I really wanted to remove what the outlier, well, the points that I personally think would be outliers, but at the same time, it did the math. The computer did the math. These points are within the mean square error of the line, and the IQR range of the line, which is annoying, but at the same time, it is what it is. The data I collected could have been better. Really, it all comes down to data collection. Really, the data I collected could have been better, but that reflection is going to be saved for the end. But if I did remove all the points that I thought were outliers, I would have lost around 20 to 25 data points, and that's almost a quarter of my data, and that's really a no-go. And this code right here, that's me right up here, is me trying to find out where the outliers are. Take a good look at it. And this is something that kind of disappointed me, kind of made me a little sad. And right here, I tried going, oh, okay, no, it's probably off by a bit. And based on the linear model, it wasn't off at all. I was just in denial, and that was silly of me for being in denial. And right here, it starts off the x and y position, like I said. The x position is the positive count. Well, that doesn't stand for position, but it stands for positive, x positive, and we got the closing value as the y. We have this all fitted for all of this jazz. We got the r-square and the mean squared error. The r-squared value is the correlation of correlation coefficient. A fun word to say right there. Is very clearly 0.04, which that 0.04 basically means there is a 0.04 chance of this being accurate. Of, if you put a, sorry, I keep on burping. If you put a data point, plug in a data point, add a data point in or whatever, there's a 0.04 chance that it will go on the line. Well, not 0.04, there's a 4% chance that it will be on the line, which is definitely the worst. It's not good at all. It is just it's not a, it's something you should try to avoid. You should always have like a high square, R square value. And the reason why I feel like that is if you look at the, there's a huge value, mean square error. It has so much leniency, especially because of how, it's set up, which I can't really change anything about setup. That's how it's supposed to be set up. But if you look at it, it has all this leeway with these data points because, look, this is around 20 data points. It's super essential, especially because I only have 92 data points in this entire thing. This is all 92. These bottom values would not make the data accurate at all. It would just make it get the data that I want, even though that's not the correct data. And so, as you can see here, that's all the data points. And really, the most accurate data is the best data, because if someone was using this data to build a machine learning model that would invest money in buying, cryptocurrency or just Bitcoin in general, if someone was using this data and just, tried to fit it, tried using my method of only using positive words and, nothing else, just positive words and the closing value, this would make them lose tens of thousands of dollars, and that would not be cool at all. So I'm going to restate myself. If I did not have these not false data points, but these outliers that, completely not ruined, but made my null hypothesis wrong, it would not be good for anyone at all, because these 20 data points, you can't just put lightning in a bottle 20 times. It's going to be really hard to do that, so these are really essential. And so, yeah. Alright, and one thing I almost forgot was that you have to interpret this data one way or another. The two ways that I personally interpret it is that one way is that, okay, you cannot use words at all to make a model or just figure out the perfect time to buy, Bitcoin. Or the other way, the way that I personally believe, is that you can't use only words to, find out when's the perfect time to buy, cryptocurrency or Bitcoin in general. And I'm going to cut to the next slide. In conclusion, as I said, it is, based on the conclusion from the test, it is safe to assume the null hypothesis previously stated is wrong. The alternative hypothesis is possibly correct, but I believe if I were to look at phrases and other combination of words instead of words on their own, I would have been able to have gotten the correlation I wanted, which the coefficient correlation I would have wanted is anything above 80, really. Because if it's something below 80, you're just not quite there. It wouldn't have been good. And the reason, like I said, the reason why the R squared value or the correlation coefficient value was so low was because the data I collected, I believe, personally, wasn't the best data because I did not use phrases or any combination of words really to find out the positive words or the negative words to the sentences and the tweets, because the tweets are fine. It's just how I use them is a little sketchy. Well, not sketchy. It's just the way I use them is not the best way they can be used. And